All right, cool. So we can get going, and as folks kind of filter in, um, we'll adjust accordingly. One of the things that I wanted to mention and bring to everyone's attention is some great work that Jeremy Howard and Rachel Thomas of Fast AI have been doing to get the word out about this Masks for All initiative. Here in the US, at least, the CDC and other government agencies have been advising folks against the use of masks for preventing COVID-19 or coronavirus transmission. But Jeremy and Rachel have done quite a bit of work that has shown, there's like, I think maybe 40 papers now on this website that seem to indicate that masks can be quite effective both in preventing or decreasing the effects of the virus for the wearer, as well as, very significant in reducing transmission from someone who may be asymptomatic to others in their community. And there are quite a few DIY masks, DIY mask videos and things like that that they link to here, as well as research on, the materials to use and other things. Like, it's, I think my take on is that the data that they've collected is quite compelling, and the creating simple masks out of stuff that you have laying around the house. There's even some videos that show using making masks out of like paper towels and tissues. And it talks about their effectiveness. And none of this stuff takes away from, the masks that, N95 masks that are needed by the frontline medical community. So I'd encourage everyone to take a look at this webpage, TinyCC masks work. There's a list of the papers. Someone from the community created a summary of each of those papers. There are links to videos, again, making, how to do DIY masks. And I'd encourage you to, if that all makes sense to you, share it with your communities. Because here in the States, mask use is not, at least in St. Louis, there are not a lot of people walking around with masks on. And there probably should be more.
They also have the advantage of, even if they didn't cut out filters, they keep you from touching your face.
Mm-hmm.
I've already shared it with my brother-in-law who's down in San Diego, and he's a former sort of maker, and he is working on prototypes to get all of the maker community into making masks. So he'll be really interested in this. Thanks for sharing it.
Oh, that's awesome. Yeah, one of the data points that was really interesting is in like Slovakia and the Czech Republic, there have been apparently like ground up movements to, spread the word on masks and, create masks. And it has really significantly impacted their, the transmission of the virus in those countries. Are you seeing anything along those lines in Belgium, Doc?
Generally, in Belgium, they advise in terms of the mask is that it's not necessary for everybody, but just for those who are actually sick already or showing signs of the symptoms, and those taking care of people who are sick should those are the type of people who really need the mask. But the advice is okay for the general public. There should be not they are advising against panic buying of masks.
Yeah, and I think, I think a lot of people are speculating that the reason why the CDC and other government agencies are advising against masks is to, you know, because they saw what happened with toilet paper and to prevent the panic buying. But you know, again, the point here is really just take a look at the data that's been collected here, and if it makes sense, you know, use it and share it.
Okay, definitely. Yeah, I think there is also some universities that they put up some websites showing directions of how to make the mask at home, which is yeah. I think there's the University of Brussels doing that as well.
Okay, cool.
Yeah.
Awesome.
Yeah.
So on Slack, I recently posted a poll asking folks about a couple of things related to the study group. One is whether a pause would be useful to allow folks to catch up, you know, in part given that we're all super distracted with lots of things, but also there are, you know, a few folks that are kind of caught up, but a lot of folks that are either, you know, a week or two behind, or, you know, expressing some interest in jumping in, but you know, could benefit from you know, some more catch-up sessions. I did a catch-up session a couple of weeks ago, and that brought in a few more people. And so I think what I'm planning to do, I didn't have an option that, you know, now that I think about it, that was, no, I don't want to catch up, or I don't want to, you know, slow down and do a catch-up session. But we did get quite a few folks, at least, you know, relative to the number of folks that replied, that said a catch-up session, or, you know, catch-up period would be useful. So what I've decided to do is insert a couple of weeks for catch-up, the 4th and the 11th. And then we will start on course 4 on the 18th. So course 4 starts to talk about deep learning and model evaluation and you know, NLP and computer vision and stuff like that. So it'd be good stuff looking forward to getting to that. But I think a couple of weeks would be good, both for folks that are, you know, again, looking to catch up, but also those of us that have, you know, that are caught up. You know, there are lots of opportunities to go deeper into the material, and we can, you know, discuss some of those on the 4th and the 11th as well. So, you know, still show up even if you're caught up, and, you know, join the conversation. And if you're not caught up, you know, we'll be, you know, it's kind of open question opportunity there for any of the lessons going back to the very first. And I'll also be thinking about, you know, different things that, you know, maybe I'll find a guest speaker or something like that for one of these sessions to, you know, keep it interesting for folks that are caught up. So that is the readout on the kind of the pause. The other one, other thing that I asked about was the time slot. You know, again, you know, when we started this, you know, for me, for example, I put it on Saturday because I'm usually traveling pretty extensively this time of year, and Saturdays were days that I knew that, you know, I could be available. You know, I'm not traveling now, and we're all working from home, and so I thought you know, it may be interesting to kind of evaluate the opportunity to shift the time slot to, you know, either sometime during the day, you know, midweek, or during a weekday day or evening. The results here were kind of inconclusive, and so I thought I'd maybe open it up to folks that are, you know, on the call to, you know, comment, you know, if any, comments around the time slot. I think this one, the kind of default now is to leave it as it is, but if, you know, anyone wants to chime in, you know, love to start some discussion on this.
So one thought I just had was that there is something to be said for creating a sense of normalcy. So shifting it to like the weekday because now we can sort of in a kind of bizarre psychological way capitulates to the disruption of the virus. And if we keep it on Saturday, it sort of reinforces this idea that we still have this structure to our week. Just a wild thought.
Mm-hmm. Very valid.
I'm open to most of those options, I think. I mean, you know, I am working remotely, so I can be available for most of those.
Cool. Hey, Jess.
Hello.
Any
Yeah, I
other
think for
takes on
me, both this time works, midday Thursday works, but yeah, I'm open to either. So whatever's best for the group.
Okay. Yeah, you know, I guess I threw it out there with the thoughts of if there was kind of an overwhelming reaction that, you know, a bunch of people said, hey, you know, I haven't been able to make it, but I could if it was, you know, midweek or something like that. But that doesn't seem to be the case. And along with Tracy's, you know, point of preserving normalcy, I think we'll just continue with the current time slot. All right, so let's jump in. So we are finishing up this this session marks the conclusion of course 3. So we're halfway through, at least halfway through the courses. Course 6 is longer because it does incorporate the project. I see now that this table capstone is spelled incorrectly both times there. I'll have to fix that. But we'll be talking about the second week of course 3 today, which is focused on pattern recognition and data mining best practices. That's what they have in this table. Actually, it's for the most part focused on outliers and outlier detection and clustering, with a little bit of a taste of the IBM's Fairness and Bias tool, AI Fairness 360. And so the learning objectives for this week in the course are, again, to get familiar with this AI Fairness 360 tool, to learn how to use outlier detection with high dimensional data, and to kind of understand the different outlier detection algorithms and how to use them in your modeling workflow. Likewise, similar for clustering algorithms and clustering techniques as well. My general take on this particular module is that a lot of the learning here for me came from the case studies, as well as links out to the supplementary materials. I think that's often been the case with this course, but even more so with this particular module. Anyone want to chime in with their general kind of reactions, you know, things they liked, didn't like, appreciated with this module?
I'm only up to question 3 on the case study, so I haven't had the chance to do that great learning yet.
Got it. Jess?
Yeah, so my comment is really kind of very high level. I think it's great that you know, a fairly big entity like IBM is actually focusing on this and building some tools for it, because I think that some of the other things I've been exposed to were different sort of libraries, and so it was kind of like a whole thing that you needed to learn separately and to kind of understand how those were working. Whereas it seems like IBM is really trying to develop a tool that people from a lot of different backgrounds would be able to access and use relatively easily. So I think that that's pretty great.
Cool. Yeah, and it sounds like there you're speaking specifically about the Fairness 360 tool.
Yeah, that in particular.
Yeah. Cool. Yeah, that is a very interesting tool. I recommend, if you're interested in digging deeper into that, to check out the website, the AIF360.mybluemix.net site. There's a ton more detail on that site. The documentations are really good. Lots of notebooks that you can walk through. We walk through in the course and in the session the basic notebook that kind of give you a taste of the tool, but there is a ton more detail there. So basically what this tool is all about is providing a set of fairness metrics and bias mitigation tools that you can apply to your AI workflows. And there are really three places that you might apply these. And they correspond to the high-level sources of bias. So one source of bias is when the bias is already in the original training data set. For example, if you don't have enough examples of a particular class, and this type of bias is corrected by what they call pre-processing. The second type of bias is when your algorithm creates a model that for some reason or another is biased, for example, towards a particular feature or set of features. And there are a set of tools that they provide for this as well. And this is called processing bias, or it's tools that work in kind of the processing stage. And then the third source of bias is when the test set may be biased. And for that type of bias, they call that post-processing. And so this is that AI Fairness 360 toolkit page. One point here that I meant to mention just in introducing this is that really this tool is an aggregation of a bunch of different papers that it's kind of aggregation and implementation of a bunch of different papers. So I think there are I want to say 14 different papers that they drew from. And well, there are a lot more references in that paper, but there's a list here, here it is, of the different papers that the tool implements for these various debiasing algorithms. But in this notebook, we really focus on a fairly simple problem. So the notebook starts by kind of explaining the Fairness 360 tool. The tool has or includes a bunch of data sets. And so the first thing we do is we import this German data set. Then the next step is to identify the protected attribute, in this case, age. This German set is basically, it's a credit data set. So it's looking at credit applications. And age is one of the attributes in the data set that is a protected attribute. So in this first step, we identify that and get rid of a couple of other features that are protected attributes, or attributes that we don't want to consider in the analysis. define a privilege class. So in this case, it's when the age is greater than or equal to 25. So you're looking for the potential for your data set to discriminate against older applicants here. And so then you define variables that represent this, whether the group is privileged or unprivileged. And then here's where the Fairness 360 comes into play. They've got, it includes a number of metrics, and the one that we explore here is this binary labeled data set metric. And you basically give it your training data set and your privilege and, an indication of your privileged and unprivileged groups. And it calculates that metric. And in this case, that shows that the privileged group was getting 17% more positive outcomes in the training data set. And so the next step is to do a reweighing. The reweighing, there are several reweighing algorithms, but in this example, we use, or several pre-processing mitigation algorithms. In this one, we use reweighing. And so you basically give it your unprivileged and privileged groups, and you do a fit transform, and you get this new transform training data set. And then you can run this binary labeled data set metric on this this new transform data set, and you see that it's corrected the difference in mean outcomes. So I forget what I was doing here. I think I was going to start to plot some of this, but I don't think I got very far with it. So this is really just a simple example of this on the on this Fairness 360 page. There's another example that talks about medical expenditure that is quite a bit more detailed, and there are some graphs that they're producing, and I think they're looking at more variations of the metrics and the mitigation algorithms. I also spoke with one of the researchers that has worked on the Fairness 360 project, and we'll be releasing that as a one of these demo casts that we've been publishing to YouTube recently. So that should be out in a few weeks, and you keep an eye on our YouTube channel, you'll see that one. Any questions or comments on the AI Fairness 360 example? Does anyone have any stories to share of how they're using these kinds of bias mitigation algorithms, or where they've seen the need for it in your work? Jess, you've mentioned that some of the stuff that you've seen has been, kind of general tools as opposed to, more specific kind of custom, a custom tool for this problem.
Yeah, I haven't done a whole lot of diving into actual tools for this. I read a lot about it kind of like ethically at the theoretical level, or kind of the ethics level.
Mm-hmm.
So the things that I've seen, I think, are like LIME and like attempts at explaining the model, because, in the thought that if you can explain how the model is, coming to its predictions, then you would then be able to see where there's bias. Whereas this kind of tool is more geared towards directly measuring bias. And so, so that was kind of what caught my attention with it.
Yeah.
And, you know, for me, if I think about some of the efforts in higher education, right? So we know that certain groups of students, you know, may not do as well or finish their degrees at the same rate as others. And so colleges and universities, they want to implement, you know, different programs and initiatives to, you know, help and support those students. At the same time, then you run the risk of sort of stigmatizing or bringing a lot of kind of bias into some other areas, right? So a really obvious example would be colleges that have selective admissions process. So let's say they're running some sort of, you know, predictive models, and they are, about what types of students you know, are going to do well, or that they should admit because there's going to be really good outcomes from those students. And they could be completely biased. And if they weren't using, you know, some type of machine learning system, then it might be really clear that there's that bias going on. But if they run this through a really fancy sort of AI system, and this is what they get, then it's almost like it removes some accountability for that. Because you can say, well, you know, this is just what our model predicts, you know, and so it's, you know, it's that taking apart of, well, why is your model predicting that? What are the features that are really going into that? And so I think it's important to do. So I guess that's kind of my easiest example of it.
Yeah.
So I have a slightly philosophical question along these lines, it's why this is not such a simple problem to attack. So going back to what I was talking about last week, in my area, looking at skin diseases, specifically melanoma, you know, we're trying to find an early detector for melanoma that could be widely made available. And yet our data set heavily leans Caucasian. But at the same time, the disease is heavily oriented towards Caucasian. So, you know, Fitzpatrick skin types 1 through 3 are more likely to have a melanoma than, you know, other Fitzpatrick skin types. So you could argue in one sense that the algorithm will get trained and will learn on lighter skin types, but in fact, the prevalence is greater there. So when have you shifted from, yeah, statistically speaking, the prevalence is in this subpopulation, and when are you sort of saying you're biased towards that population?
Right. So that's a really interesting point that I was, you know, kind of getting my thoughts around. So there's sort of this mathematical bias, right, which is a little bit kind of what you're describing there. You know, that there's a weighting towards a certain group because that is sort of the stratification that you're seeing, you know, in the world or in that field. And then there's kind of, with my example, where the bias is the more like traditional, you know, like common usage of the word bias, where you're sort of marginalizing or doing something detrimental specifically to one group. So I think there is a difference there, and that they, you know, really shouldn't be conflated. And I think they often are conflated, and you know, when you get into some dialogue. But I think those are really kind of two different usages, I guess, like of the term bias.
Yeah, and I think the tool is meant to cover both of those in different ways. The I think some of the reweighting, for example, you know, can be used in a situation where you're trying to address the mathematical bias, and that may or may not also be related to a kind of an ethical bias, if that makes sense.
Yeah, I mean, if you're trying to like kind of predict a rate, you know, then I could see where, you know, the incidence between different groups of people is actually just kind of a, you know, it's a fact, you know, that there's a different incidence, you know, in different groups of people, presuming that, you know, everything has been ethically done up until that point, you know, to come to that conclusion. But then when you have a tool that you're trying to recognize whether something is, you know, a cancer or not cancer, then I think you actually do want that tool to work equally well for all the different skin types, even if the rate of it in a particular skin type may not be as prevalent. So
Yeah.
you kind of have to think about the actual case usage and what is this tool trying to do, right? So if it's trying to identify it, then how common it is in a certain skin type maybe is actually less important in that specific tool.
Yeah, it still is a bit of a fuzzy area. And even let's take a more extreme binary example. So I've developed a tool to develop or to a test that will predict your likelihood of getting testicular cancer. All right, but I've got to make sure it works on across the population equally. You know, obviously that's nonsensical. So where you know, it's just a complex problem. I think I'm really glad that there are tools like this Fairness 360 to at least get us to think about the issue more deeply than just kind of blow it off. We also have the advantage, certainly in the research side of things, that the review boards always demand that you're explaining why you're excluding a population or, you know, not sampling from the population correct, you know, uniformly or at least representationally.
Yeah, and I'm also hoping that, you know, some of these kinds of tools can really help make some strides in women's health, because women are another sort of category of individuals that get really underrepresented in medical studies, and yet lots of conclusions are drawn, you know, in terms of like what the risks are, and they could look very different for men and women.
It sounds like, I mean, I guess what I'm coming to is that the reweighting algorithm is, or something like that, tools like that are helpful, right, in highlighting bias for us. And then I think it's up to us to then use our sort of, right, ethics and our insight to, our qualitative insights to then determine, is this bias a bias that is concerning, or is this bias a bias that makes sense given the whatever we may be looking at? In the case of testicular cancer or melanoma, does the bias make sense? And then from there decide what we do with it, I think. And I have a technical question. I don't know, I looked at this paper on the reweighing algorithm, but does anyone have like a very sort of maybe it's cited here in the example. If you guys, does anyone have like maybe a simple way of explaining what this algorithm is really doing? Like, I get using it in this example and getting the result that we do, but what actually happens underneath the hood? I don't know if anyone has any experience with that or deeper understanding what happens underneath the hood of this algorithm.
So you can pull it
Yeah,
up.
that paper. That's the paper I was looking at.
Is it this one?
Yep. If not, no worries. We don't have to spend too much time on it now. It was just seeing if anyone had any understand what's going on underneath the hood here.
Yeah, I did not look at this paper in any detail, but we talked about the imbalanced learning stuff and SMOTE and some of those others last time. And I did look into those a little bit more detail. And I think this one was talking about resampling the data. So it's going to be some variation on a similar theme. The SMOTE paper is actually fairly accessible and covers the background pretty nicely. And I also came across this blog post on machinelearningmastery.com that kind of talks about the SMOTE algorithm. And I think the pictures go a long way of explaining what it's doing. So you've got, in this case, you're trying to do some classification, and you've got this class imbalance where you've got a lot of samples of this blue class and a few samples of this orange class. And so what this SMOTE algorithm does is it oversamples the orange class. So it increases the number of samples of the orange class. And notice that like the shapes, you know, if you look here you still have, you have holes like here and here and here. And so what it's doing is trying to come up with a way that oversamples this class that doesn't change the distribution of the class statistically. And you know, so that's kind of the way that this is what, you know, the SMOTE algorithm is doing. I imagine that the reweighting algorithm is doing something similar. You know, maybe if you graphed it, it would look slightly different because of some of the choices that it's making. But it's, you know, generally that's the idea here. This one, so in the SMOTE paper, they recommend apparently that in addition to applying SMOTE, you can increase performance further by random undersampling everything once you're done. So removing samples of both classes, and it might look something like this. And you can get a sense from looking at it that it's kind of maybe more natural in some way. So I can take a look at this paper, but my sense is that it's probably doing something, you know, fairly similar.
Got it. Makes sense. And I'll take a look at it too. I mean, just wanted to ask and see if anyone else had. But it's helpful. And actually, I was not aware of that machinelearningmastery.com website, but I'm gonna jump on there and dig through that as well.
Yep. Yeah, this is a good one. And he does a lot of, like, it has a lot of code samples in Python for various different techniques. And someone asked about, was it the last time, it wasn't the ADISON, it was SMOTE Inc., which was for non-continuous. I don't know that that's covered here.
Seems like this might be a good opportunity for a sideband discussion on Slack. So if we posted it as like a question there, then we could have sort of a threaded discussion on that paper.
Great idea.
Yeah, I like that too.
Agreed. Thanks, guys.
Awesome, awesome.
Yeah, I mean, one of the things that often comes up too, talking about bias, is that the viewpoint that, you know, if you're talking about kind of the more colloquial use of the word, is that if society has a bias, then why shouldn't that be reflected then into the models that we build? And I think, you know, there's just a lot of dialogue around those kinds of things, because here we're talking about these very practical uses like classifying images and that kind of thing. But then there's also, you know, systems being built like for HR purposes, like for hiring. And so then they're basing, you know, off of things like, you know, what are the characteristics of the individuals who have done really well in this whatever position or another within this company. And so, of course, that's going to generate a model that replicates the traits of the existing people. So it will then perpetuate any systemic bias if there is systemic bias there already. So I think that's kind of another angle of this.
Yeah. Yeah, there have been a few examples of companies that, I forget, was it LinkedIn that shelved a tool that they had developed that, maybe not LinkedIn, some company had developed a tool that they use for screening resumes, and you know, it turned out it had, you know, exactly this problem you're describing, and they ended up needing to shelve it.
I think it was Amazon. Was it
Amazon? Yeah, that's right. Yeah.
Yeah, and you'll see the same things in like high stakes admissions and things in some higher ed applications.
Cool. So that's AI Fairness 360. The next section of the, you know, this unit talks about outlier handling. So I think outlier, you know, the outliers are defined there. Data points are observations that fall outside of expected distributions or patterns, but it's pretty much what it sounds like. They do introduce this idea of outlier versus novelty, where the main idea is that you think of something as being an outlier if you know, it's a problem with your training data and you need to do something or, you know, get rid of it or something like that. Whereas the idea of novelty is like you assume that if you can assume that the training data doesn't have outliers, then you may still want to identify points that, you know, are quite different from other points, but you're not kind of assuming them to be problematic and, you know, necessarily removing them from, you know, whatever you're doing. And so some of the algorithms work equally well on outliers and novelty. Others are, you know, tend towards one or the other. The course talks about 4 main outlier detection algorithms: elliptic envelope, one class SVM, local outlier factor, and isolation forest. You know, this is getting close to, you know, this is one area that's getting close to, Jess, you had mentioned a few groups ago, you know, we need like a flow chart for all these kinds of things. This kind of gets there. You know, whereas, you know, hey, is your problem outlier detection or, you know, novelty? Well, that cuts out some of these. If local outlier factor works well on high dimensional data sets, whereas elliptic envelope doesn't. So there's some of that information here. But what I found even more interesting was on the scikit-learn site, they do a comparison, a visual comparison of some of these algorithms, and there's an interesting discussion of them as well. One point to notice is that, you know, as you can see here, these are all ellipses. This robust covariance, what they're calling robust covariance method here, is the elliptic envelope method. And the issue that it has is that it doesn't perform well, or it may not perform well in high dimensional settings. And so if you want to try to use that, you're encouraged to do dimensionality reduction first. One class SVM is this second column here. You see that it, you know, seems to perform pretty well in identifying these outlier samples here. You do need to choose the type of kernel, you know, a la linear, polynomial, the RBK, and there are others, and set some parameters to help you define the boundaries. Local outlier factor, this is one that works well in these high dimensional data sets. It uses the radial basis function, RBF, as the kernel. You see this one does fairly well, but it also kind of looks like it's maybe overfitting a little bit, or, you know, it's fitting very tightly. And so that may be something to keep in mind there. And then isolation forest works like random forests, and it has several tunable parameters. In the description on this page, they don't mention anything about why there are no lines here. And so I'm not sure if it's just a broken page or if the idea is that it perfectly isolates each of these outliers. I don't think that's the case. I think the plotting is broken in some kind of way. But that's another thing that I wanted to follow up on. Does anyone have any ideas on what might be happening there?
Well, no, I'm looking at it and I thought maybe some of the dots themselves were representing what to look at, but now I think maybe not.
Yeah.
Like it doesn't it look like some of the blue dots are a bit larger, so.
I don't think so.
Yeah, it's hard to tell.
Yeah, so this is the page here, and I have not tried to copy this into a notebook and run it and play with it. That will be the next step. But there doesn't seem to be.
It is weird on that smaller. If you go down to row 3, they're right there. Look at the little cluster in the sort of the lower left quadrant. It has blue dots around it, whereas none of the others do. So that's kind of weird.
Like where here?
One up, one more, right? Go there, that one.
Oh yeah.
Yeah, I think it's somehow representing like that specific data point, like how, you know, how much it is an outlier. And so then, you know, there may be some significance, I guess, in those points. How the points are clustered, because it's each individual point rather than like a section or like a grouping of looking at the points, if that makes any sense.
Mm-hmm. Yeah, I mean these. Yeah, you either have here, this is orange and this is blue everywhere else. They look, the points look similar enough across these examples that it does not seem like they're, you know, randomly distributed from one to the next. But this.
Yeah, but I think Jess is right, because if you look at everything inside of the black boundary is one color and everything outside is the other. So in the last column, they haven't bothered with boundaries like that. They have, looks like they have just colored individual dots.
Yeah, because it's like a point by point. It's like, it's not this, you know, grouping of data points. It's this specific data point. How much of an outlier is this specific data point?
Ah, got it. Cool. So I pulled this one I came across just as I was pulling together, preparing for this particular session. So I didn't get a chance to read this in a lot more detail, but it probably does explain it in here. But that, I think that what you're saying makes sense, and I'll be digging more into this to, you know, make sure I understand what's going on here. All right, cool. So, but thank you for that. Let's see, where are we? Slides go. All right. So we come back to the, so that's outlier detection. Any other thoughts or comments or kind of experience shares on outlier detection? The next thing we talk about is clustering. Generally, I think we're all familiar with the idea of unsupervised learning. With supervised learning, you've got labels. With unsupervised learning, the patterns are found in the features themselves. Clustering is, a popular type of unsupervised learning. They present several different types of clustering algorithms. There are the combinatorial algorithms like k-means that are based on kind of geometry and treating the different observations as points in space. There are the mixture modeling types of algorithms like Gaussian mixture model and Dirichlet process mixture model. These are based on the idea that the data is drawn from some finite set of distributions. The materials mentioned mode seeking, but not any particular algorithms. Mean shift is an example of a mode seeking algorithm, but it's not discussed very much. And then the materials also mention ranking systems, or these clustering algorithms based on ranking systems or transformations of data, in particular spectral clustering and affinity propagation. They're not mentioned much at all in the materials, but they do pop up on the quiz. I forget the question. It is one of the questions on the, where did it go? One of the questions on the final quiz asks which one is good for graphs. So I ended up having to look that up because I didn't find it in the materials, but this is another example of where in this particular course, like a lot of the detail is in links to, either Wikipedia pages or sklearn documentation. And neither of these comes up in the case study. So the next set of things that's discussed is, basically when you are using clustering, most of these methods require you to choose the number of clusters and then optimize on that. And so you need some way to evaluate the performance of your choice of that parameter K and optimize the performance of the clustering technique. We don't have labels, so you can't really use cross-validation. So, in some ways you're kind of, looking for something that is, good enough and making a judgment call based on it. There are 3 different kind of categories of clustering evaluation techniques that are mentioned. There are the adjusted RAND index and normalized mutual information score. These are clustering performance metrics that you can use if you actually do have labels. So sometimes you will perform clustering and then kind of manually, attribute each of the points to a label, so you've got some kind of ground truth. And if you do have ground truth as to what clusters your labels belong to, then you can use one of these types of metrics. More often though, because you're doing unsupervised, you don't have labels and you don't have kind of these absolute clusters that you could label to. And so silhouette score seems to be the way to go there. Davis Bolden is mentioned and linked to, but not really mentioned much. It's mentioned but not elaborated on. There's also a mention of a method called the elbow method. If you look at the Wikipedia page there, it basically says use the silhouette score, not the elbow method, because it doesn't. It's not that consistent. So the silhouette score is basically a method of, it looks at the validation and consistency of points within the cluster of data. And so each of the points gets the silhouette score that measures how similar, measures kind of cohesion, how similar it is to the other points in its cluster compared to other clusters. And the score ranges from 0 to 1. The silhouette score Wikipedia page is pretty good, but math oriented. Basically, the way the score is computed, it computes this A metric, which is basically the mean distance between the point that you're looking at and all the other points in its cluster, the cluster that it's been assigned to. And then this B metric is the mean distance between the point and all the points in other clusters. And so the silhouette score is calculated as B minus A over whichever is bigger. And if you can kind of get some intuition for this by thinking about if you've got really good clusters and you have a point that is, what is a really good cluster? Really good clusters mean, well, the point, a given point is very close to all of the points in its cluster and very far from all of the points in other clusters, in which case your A is going to be very small and your B is going to be very big. And so if B is a really big number, or say non-zero, and A approaches 0, then this is going to be B on top, and your max is going to be B on the bottom. So that's where you get the 1 from. So if you got a silhouette score of 1, that's that point is kind of in a good cluster. And then if you think about it the other way, what's a bad cluster, or a point that is clustered poorly? You would have A that's very high. The point is far from the other points in its cluster, and B, it's closer to a lot of points in other clusters. So this mean would approach 0. So then you have negative A over A, and so that's where you get that -1. And so this method can be used again to then tune your number of clusters in your algorithm by running it given a K, evaluating the silhouette score, and then doing the same thing over several values of K and choosing the one with the best silhouette scores. Any questions on any of the clustering section, or thoughts, ways that you've used this?
Just a question.
Yep.
I was just wondering how would this score perform in the case of like the DB scan clustering algorithm?
So how does it perform?
How was it perform? Because given that it looks at on average the distance looks at the difference in the average distance between itself and the points within the same cluster, as well as in relation to points on different clusters. But for an algorithm like GB scanning, that you could get some, you don't really get you could get some clusters that are like overlapping, close to overlapping some other points that are in another cluster.
So you're like, for example, if you get if you have clusters that are like concentric circles or things like that, or I'm thinking of pictures like,
things like that.
Yeah, that is a good question, and I wonder if this mentions silhouette score or a particular metric that is best to use with it. I can certainly envision situations where your cluster structure doesn't lend itself to this metric.
Yeah.
Although you do have flexibility, like you can compute the distance in different ways. I'm not sure if that helps, or if the if the issue like lends itself to or is related to the number of dimensions or something like that. But yeah, even these concentric circle examples,
Yeah.
you can imagine where the silhouette score might fall apart.
Yeah.
Anyone know or care to comment on that? I think that's a question for further study and something else that we can follow up on via Slack. All right, so the case study here goes into, again, we use both the classification and clustering are kind of illustrated here. The scenario that we're given is that we want to try to predict customer retention. So we've got this stream data, and we want to try to predict whether, we want to try to create a classifier that can predict customer churn, essentially. And we want to see if we can use use clustering as a way to, as part of that pipeline, to improve the performance of our classifier. And so we're kind of guided through this process of creating a churn model and then using clustering as a part of the churn model to see if it performs any better. And then we also look at resampling to see if that improves the performance of our model. And then I also added a step here, looking at a very, very simple outlier detection approach based on an observation, and we'll talk about that. So basically, the first step is setting up your data. So you're loading your data. This is given in the course, the Avail Target CSV. You are here, you're getting rid of some columns that you don't need, and this is basically their approach to negating this column. So you've got your column that is subscriber. This is, if they're a subscriber, they have not churned. So what you are really wanting to predict is, has churned, and that's the opposite of this. You can also just subtract it from 1, which I may have done in here somewhere. But that's, you're basically creating your Y column. And then you're doing your test train split, and you are using this stratify method, which basically does some balancing for you. And then you are creating a model. And so they give you this pre-processing pipeline to work with. Basically what you're doing is you're scaling and you're imputing missing values and scaling your numerical features. For your numerical features, you're imputing missing values using the mean strategy. So the mean of the column, and then you're scaling those values. And then for your categorical features, you're filling missing values in with the word missing, and then you are one-hot encoding your categorical features. And then you're setting up a preprocessor pipeline step that performs these on your numerical and categorical features. And then you're asked here to create a baseline model, baseline classifier. In the my first attempt at this was very simple, just kind of a a basic SVM without doing the grid search or anything like that. But this is the doing SVM and grid search is something that we looked at last time in this fashion MNIST example that was presented. So a lot of my starting code came from here. This was presented in one of the videos, and I said that I would put this in GitHub and share a link to that via Slack. I had not gotten to that, so I apologize for that, but I will do that today for kind of all of my materials so far. But basically here, you are creating a pipeline that includes your pre-processing and your SVM, doing grid search on that pipeline, looking to fit these parameters, your C parameter and your gamma parameter for SVM. The SVM doc page is very useful for referring to all of the different parameters. And then you do the same thing for random forest, or you can do the same thing for random forest. This is the approach that they, in the solution, they look at both SVM and random forest, and you can choose other classifiers and test those as well. So you run those. In the process of running those, they also tell you what your best parameters are, and you can save those for later. So in the next, for question 3, they are then asking you to, this is where we start to try clustering to see if clustering our data before we do the classification and adding the predicted cluster as a feature for our classifier helps at all. So here we look at 2 different types of clustering, k-means and the Gaussian mixture model. And they give you the functions for these. And then we try both of these with the input of the number, there are k, basically the number of clusters being set to 4. And the code they give you just prints out the shapes, basically saying that what, we started with this 7-column wide matrix, and then we add on the columns associated with the 4 clusters. So kind of a one-hot encoded 4 kind of bit one-hot encoded additional columns, which will say whether a given point falls into a given cluster. And then they hand the reins to us to basically implement this into the pipelines that we created earlier. So if you set this up using a pipeline, it's fairly easy to stick this in there. I first tried to run grid search on this final pipeline with the idea being that maybe your parameters might be different. If you know, if you have the clustering information available, then if not, but it did not like that. That did not work at all. It blew up. So, and what the solution does is basically takes the parameters that you found earlier, actually up in question 2, and use those to create your SVM model, and then just fit your data to that pipeline. And so then you're, you know, all the time here, you're printing out your F1 scores to as your primary performance metric. And then, so this was my first step here, is just kind of sticking in these transformer, these clustering transformers that they gave us and kind of running them with the K, with the, you know, K set is 4. In the solution, what they're doing, this is not exactly the way it's done in the solution, but the idea is the same. You're then trying to essentially do a search on this clustering parameter K, and so you create a pipeline that kind of parameterizes the model that you're using for your classifier and for your clusterer. We do it slightly differently. I basically set up dictionaries, and they use if-thens here, and you fit your pipeline, you predict your, you know, on your test set, and then you return your F1 score, and then you can iterate over the various combinations of classifiers and clusterers and produce a table. And then they ask you, okay, does this change anything if you introduce the resampling technique? And so basically copied the code here, inserted SMOTE. This is basically from the solution. And, you know, neither I nor the solution played around with, you know, different parameters for SMOTE or different resampling techniques. But you see that it does not change much. And there's a little discussion paragraph in the solution that, you know, basically says, hey, the things that we're doing, you know, adding the clusters and resampling, you know, don't produce, you know, don't necessarily change our performance quite a bit, but hey, these clusters may still be useful for the marketing team and like planning campaigns or something, but they don't necessarily improve our classification performance. And the data reflects that. So one thing that I observed in looking at this data is if you look at the original data set, the age column, you know, has some negative numbers in it. And this is basically because of the way that the age is calculated. You set a threshold year or threshold age that, you know, before which, if you're doing the date math, you have to set there's a default threshold, and if you don't override it, basically it assumes, I forget what the year is, like 1978 or something like that. But there's this built-in threshold in the process that if you don't pay attention to that and just do it without tweaking that parameter, you'll get, you know, some negative ages. And so I noticed that when I was looking at the data set, and so replace those with not a number, just using fill and a. And then this is basically like a simple imputer kind of thing. I replaced those NAs with the column mean. And then did the, recreated the training data, and then ran this again. And this actually produced, more of a lift than any of the other stuff that we did. So I thought that was kind of interesting, and an example of, paying attention to the outliers, even though it wasn't included in the, this case study per se. So the solution that they have is, for the most part, fairly similar to this one. And again, I will today gather up all my stuff and put it into a repo and share that. Any thoughts or observations or questions or comments relating to the case study?
Sam, I caught the same thing you did on the age.
Yeah.
I thought it was, and I probably wasn't right on this, I thought it was okay to maybe just assume that that person was 46 years old and not negative 46. But I'm not aware, what is it that, so it sounds like it's not safe to assume that. And so what is it in date time that causes that error? And is there a way to actually determine the true age, or should we just do, is the best thing to do in this case then do what you did, just get the mean?
Yeah. Let me try to find, I spent a lot of time on this in one of the previous modules. I think it was the, I think this is the approach that they used. And so the data ingester, I'll see if I can find the thing that I'm thinking of. I don't think it's this one. There's that very first case study, like they glossed over the calculation of the age, and I did it fairly differently and noticed, it just caught my attention that, there was a possibility of introducing errors there. So I remembered it when we came to this.
I remember doing the same sort of thing, but like you, I can't remember what it was that I did. I think it was almost like a Y2K bug kind of thing.
Exactly. And so I ended up with a separate, like a totally separate age function, and I was like having to tweak the parameters and could never get it quite perfect. It may be not in this folder. I think everything is there. This will also be a Slack follow-up.
So I'll go back and look too, because I do, now that you guys say that, I do recall us having a discussion on that at some point too. So I'll go back and look at my case study as well.
Yeah, let's see. Oh, that's not useful. I tried to like grep for age in the directory, but that doesn't work too well with notebooks. It would have been.
Gee, I seem to remember a big discussion about taking your code out of the notebook and putting it in something you import somewhere.
That's right. And was that course 1 or course 2?
The age thing or the encouragement to put stuff in, put code outside of the notebook?
The data ingestion thing in general.
Course 1.
Where is my course 1 stuff? My course 1 stuff I did on Watson.
Yeah, and Tracy's right, because we had to create a data ingester py file, run it from there, pulling it out of notebooks.
This is the dashboards project. Yeah. Module 1 case study. Let's see. All right, so all right, yeah, so you're adding a column for age from the date of birth. And the way they did it was, let's see. Oops. For where did we go? I may have just looked at the case study, maybe in Coursera, but basically, I think they did something. They did like a subtraction or something like that that produced the. Actually, no. That file. This is what they did here. They said the age. They use this, let's see. So for each of the ages in the column, they did, so they start here. Yeah, so they're subtracting today from the date of birth, and then they are kind of casting it with this time delta thing. And there's a thing with this time delta thing where it is it time delta? Gosh, I'm forgetting. I spent a lot of time looking at this before, and I don't remember the details. But suffice it to say, something in there, like there's this implicit threshold of the relating to the, I think you have 2-digit years or something, and you're converting them to 4-digit years implicitly in that process. And there's an implicit assumption based on the 2-digit year, which century it is. And that ultimately is the origin of the problem. And so what I ended up doing was creating a function that makes this more explicit and defined a minimum customer age. And then I do all of these calculations based on the minimum customer age. And so, the only time you would get a negative is, you wouldn't get a negative unless you are expecting to have customers less than 10, and you'd have to tweak this. And so then for my age function, I printed the minimum and maximum customers and confirmed that they were all positive. But again, I'll share this so you can dig into it in more detail. But needless to say, their process results in these negative numbers, which I think it is more fair to interpret those as not flip signs, but mistakes that are introduced in the processing pipeline. And rather than, like, the real thing to do would have been go back and fix that. But I thought it was interesting for the purposes of this lesson to say, oh, well, these are maybe outliers that are, maybe kind of analogous to some data that's introduced by a faulty sensor or bad data collection or something like that. And so what is the impact of just, doing mean imputation on those? And it actually helps quite a bit.
That makes sense. And I think I went backward and looked at course 1 too. I think it didn't help that their solution had this, but the data set they gave us, the actual database, already had age in it. And so I think there's some confusion there too. I remember. But no, I think it makes sense. I think you're right. The mean, for the purpose of this lesson, taking the mean helps see how that affects the overall result. So
yeah,
appreciate it, Sam.
Yeah, I mean, we talked about in that in a prior lesson, the different imputation approaches, and another approach would have been to just drop those and, drop the entire row and, see how that works. But yeah, the mean seemed to work pretty well. Any other questions on this case study?
Nope.
All right. How about other, general questions, resources? Tracy, I think you shared something in in Slack. This was related to the topic modeling.
Hi everybody, I'm Andres Nistolis and I'll be talking about LD.
You recommend this video for digging into LDA and how it works?
Yeah, at least for me, I tend to be a visual learner, so I thought he did a particularly good job of the ones that I sort of scanned and explaining it.
Cool.
I also had a question about the fact that all through the tutorials I was looking at, people were using, I posted that as a question on Slack as well.
Densim versus Spacey.
Yeah.
Yeah, I think I would recommend maybe checking out this podcast that I did with Inez Montani. She's one of the co-founders of Explosion AI, who develops Spacey. But if I remember correctly, one of the big things that they were going for with Spacey was performance. relative to GenSim?
I thought I saw that somewhere, like on their page probably.
Yeah.
And they
Fast,
seem to also be like,
ready.
we're very pragmatic approach seemed to be what they were going for, I guess.
Yeah. Yeah, and this looks like you can use them together as well. But yeah, this was a good chat if you want to dig into that. And this looks really interesting. I wonder if I can find the so don't know if any of you have come across Fast Forward Labs in the past, but they were a kind of a practical research company founded by Hillary Mason. So this is a really early podcast where we talked about what they were doing there, and they produced these research reports on various topics. And one of them that they did was on text summarization, and it uses LDA and talks about language models. And the report was really interesting. And they recently, I think I know they made their latest research report available publicly. So they were acquired by Cloudera, and I know they made their latest report available for free to the public. I thought they were going back and making all of the older ones public as well. It doesn't look like that's the case. So never mind, but they had a really good description of LDA and topic modeling and how it's used for text summarization in this report. If anyone is interested in that, let me know and I might be able to get you access to it. Cool. So any other thoughts, questions, comments?
So one of the things that I'm finding, and this is a kind of an unexpected, I don't know, benefit from the class, is I find that I have been sort of sloppy or lazy with respect to some of these tools. I've just considered it in the past to be fine to like scan, sklearn or whatever. Yeah, I'm kind of familiar with it. But I think for me, a benefit is this is really forcing me to just dig in much more deeply and broadly than I have been doing. And I'm just wondering if that's anyone else's experience or if everyone else is like, oh, of course I, really dug broad and deep in this sort of stuff. Or if anybody else is sort of, it's like causing you to up your game a little bit. Like I feel like it's really forcing me to up my game.
Yeah, I would say I have the same experience because I'm very opportunistic. Like I'll look into whatever I need at that moment and then, not necessarily a lot outside of that.
Yeah, I think that describes me as well.
Yeah, I think that's the case for me as well, with a particular emphasis on like the pipeline, building repeatable pipelines and putting everything into functions. Like, my typical, using a notebook, it's like probably the worst examples of using notebooks where you have cells all over the place that are run all out of order. And, if you shut everything down and come back to it and hit run all, it never works because things, the state is all wonky. But I think one of the explicit goals of this course that has definitely been useful for me is kind of building the discipline of encapsulating things and, you know, using tools like Pipeline and sklearn, you know, or other approaches. You know, there are other approaches, but, you know, building, you know, these things that are more repeatable so that you can then, you know, experiment more easily, more repeatably. Jose, I saw you unmute there. Did you have something to add as well?
I was gonna say the same. I think to Tracy's point, it's like the question I had earlier on the reweighting. It's forcing me to go back and look at documentation on all these tools and not just take what they do for granted. And then similarly forcing me to, I think we all have a tendency to, as you said yesterday, just grab a tool and use it, but not necessarily slow it down. And like you said, Sam, like actually structure it so that it's repeatable and scalable every time you come back to whatever file you created. So I'm finding the same by going through the course, which is helpful.
Mm-hmm.
Well, thank you all. I feel a little bit more normal now.
Awesome. Any other comments or questions, topics? Anything? So recall, like, we're going to do these catch-up sessions. Sounds like most of us on this call are, or, you know, several of us on this call are kind of caught up. I know Da is, you know, starting from early in the course. Wendong, I didn't get a chance to say hi to you, or we didn't get a chance to say hi to you, but hi. Where are you at with regard to the course so far?
Hi, Sam. Yeah, kind of just catch up and follow the slides, the session. Yeah, I think I understand well because I have experience in this area. Just try to refresh the concept, the ideas.
Okay.
Yeah.
So I mentioned at the beginning, I forget whether you and Jess had joined yet, but we'll be inserting a couple of catch-up sessions over the next couple of weekends. And the idea there will be that, you know, any questions are open, whether, you know, independent of the course that it corresponds to, and we'll also provide an opportunity for folks to, you know, go deeper into the material and areas that that are, you know, that have caught your eye or have been interesting. It just occurs to me one thing that might be interesting if you all are game for it is to have folks, have you all, you know, research or dig into deeper particular topic that is, you know, interesting, relating to what we've talked about in the first few sessions, and be prepared to, you know, give a small presentation on it. Is that something folks might be willing to do?
Sure. Might need some help doing it, but yeah, that'd be fun.
Cool. Tracy, you unmuted, but you haven't said anything. You on the fence?
I'm debating what. Yeah, I was going to say, I think I'm going to be gone that weekend. No, it would be kind of like even the whole class. It would certainly act as a forcing function to drill down on stuff.
Which weekend are you talking about?
So the next 2 weekends, and you know, if we get if 4 of us, you know, say that we're interested in doing this, we can plan to have like 2 mini presentations on each of the weekends, in addition to kind of the general catch-up stuff.
I think I better not commit myself to that since I have the Fast AI study group with a lot of beginners, and so I'm preparing a bit of material for that.
Okay.
I am also going to sit on the fence a little bit because there are some other projects at work that are, I don't know if it's going to be too much competition.
Okay. Well, Jose, do you have anything in mind that you might want to dig into, or do you want to think about that a little bit?
Let me think about it, and then maybe send you a message, Sam, and if maybe prepare something for 2 weeks from now.
Okay.
I don't know if that'd be okay with that. 1 week. I don't want to commit to something now or not be able to do it. But let me think and then follow up.
Cool. Yeah. And how about Da and Wendong? I know you're, well, Da, you're just getting started, but certainly you're welcome to do something from one of the earlier courses, and Wendong as well, if based on your experience. Either of you?
Let me think about this.
Okay.
As for me, it's a little bit close. I might not be able to do it in the next week.
Okay.
So, yeah, I think I'll need more time than everybody to come up with something.
Okay. Well,
Yeah.
Well, I will also mention it in Slack, and if any of you have ideas or want to jump in or sign up to do a presentation, now or really at any time in the future, I think that would be a great add to these sessions. Are there other things that would be interesting to do to supplement kind of general back Q&A over these next couple of weeks to kind of give more life to the material, more context? Any ideas on that?
I don't know. There is something that I always wanted to look at, and I don't know if someone else has also been thinking about it. For example, when you talk about the smooth, seems as if you guys looked at that last week. Yeah, those techniques for trying to adjust or to account for biases. And I often wonder, which is something maybe somewhere in the future I would like to give a presentation on that, because I'm still working on it. Try to look at how they actually affect how those adjustments actually affect the modeling. Because from a statistical point of view, those techniques often change the entire data generation mechanism. And if you change the mechanism and you use that as a prediction, how does that actually affect the model when it's in production?
Mm-hmm. Yeah, that'd be great.
Yeah. Okay, then I would prepare maybe something on that, but a little bit further in the future, not in 2 weeks. Yeah. Yeah.
Any other thoughts?
Sam, do you have any maybe guidelines on what you're thinking in terms of presentation, just so even if it's not in 2 weeks, right? Like, how would you like to see it there?
Yeah, it doesn't need to be complicated. I think even, it can be, either it could be something as simple as like, 10 or 15 minutes of, we glossed over this topic in, course 2, week 1, whatever. It caught my interest and I wanted to dig in. So I read all the docs and, these are some of the things that, I gathered, I really dug in, this Fairness 360 thing was interesting. I read a paper. This is what I got from the paper. It could be, like this age thing that we were talking about, like, surveying, how these kinds of problems come up. It could be anything really. I think it's an opportunity for for those of us in a group to just pick a topic and dig into it a little bit deeper and share what we've learned with the rest of the group. It doesn't need to be for that matter, it could even be like leading a discussion around a particular area. It doesn't even need to be a formal presentation, but it should probably be something that you've found interesting and dug into a little bit and that you want to share with other folks. Hopefully that makes it less scary.
Makes sense. Appreciate it. Helps a little bit.
Actually, I have a real world problem that I might do a little mini presentation, not in 2 weeks, but down the road here, just to simply get some other ideas, critiques on approaches on it. So I'm going to be doing some clustering of images, and it will be interesting to hear, as I say, I'm approaching it this way and I'm doing this, and have other people sort of say, oh, have you thought about maybe doing it this other thing? Or, so that could be really helpful, actually.
Cool. Yeah, that'd be awesome. All right, great. Well, thanks everyone for jumping on today. Looking forward to seeing everybody next Saturday, and I've got a couple of follow-ups. One is to get this stuff on GitHub, and then I had a note to follow up on the age thing, but I think that we discussed that quite a bit, and you'll be able to see what I did in the GitHub stuff that I share. And then I've got to follow up on the DB scan thing. I think there was one more thing that we said that we were going to follow up on in Slack, but I do not have it written down. Does anyone remember?
We talked about the age thing as well, but that makes sense. The unusual ages that were found in the data there. But I think that's an easy one to dig into. I'm not sure we need to. That doesn't have to be a big discussion. The other one I think is interesting.
Okay.
I think the other one was it has to do with the weighting.
Oh, the reweighting paper.
Yeah, the reweighting paper.
That's right.
Sure. Yep.
Thanks, Doc. All right, cool. Well, see all of you on Slack, and see you next